neighbors, and n plus 1 is the number of splitting in a particular peak. So by counting the splitting, we can say how many neighbors that set has. We can't say what that set is or how many protons are there in that set, but we can say that that set of protons got this many neighbors. Okay? So that is about the splitting. And the last information is about integration. So what you will see is in your question, they will say this is the peak, this is quartet, like say this one is triplet at sigma or delta, sorry, the midnight. So 2.2 for integration, they will call it 4 hydrogen. Say I'm saying I for integration, just to make you guys understand. Okay? If integration says 4 hydrogen, it means now this peak or this set of proton has 4 hydrogen. So these are the bits and pieces of information you get, and now you have to keep it together to make a spectrum. Okay? Or to pull out the information from the spectra and keep them together to make a structure. I always recommend that once you come to your final structure, don't look on your question and draw a spectra like for that particular structure and try to see whether that matches to your problem or not. If it do not match to your problem, it's not right. Okay? So let me go over some of the examples like 2, 3, and that will make it more clear to you guys. I will go over one of the examples you have in your lab report. And I ask you guys, if you want to take your lab report back for IR spectra, you can take it, you can submit it next week, okay? So you don't have to submit it this week. If you want to take it back, take it back. Okay, let me go for... Guys, I am going over one of the questions which you always have trouble with from the last lab. No? That's why we have. Okay. So the last lab, you had a problem with C4H8O2, and there were 2 spectra for this. These are the last 2 questions which you guys submitted with the confirmation analysis. Okay? One spectrum was singlet at 4, say 3.7 I will say. Then a quartet at 2.25 or 3. And then a triplet around 1.2. This is one spectra for this chemical formula. The second one was a singlet at 2.3. And quartet at 3.8 and triplet around 1.5 or 6, I don't remember exactly. Okay. So these are the 2 spectra given into your lab manual which you have submitted with your confirmation analysis lab report. Now, from this spectra, one thing is very clear that there are 3 sets of protons. Okay? The second thing is, we are looking on, we have in the molecule, we have 2 oxygen atoms, which are quite electronegative. And looking on the spectra, we can see there is one set of proton which is directly attached to the oxygen because the spectra has been shifted to 3.7, around 4. drawing. Otherwise, it should come around 1.1, 1.2, 1.5, 2.9 or something like that. If a CH3 is not attached to any electron withdrawing group or any electronegative atom, anyhow, then the peak will always appear around 1. And depending on its distance from an electronegative atom or electron withdrawing group, how far it is or how close it is, it will shift the peak position from 1 to 1.5 or it will keep at 1. So say if it is CH3, CH2, Br, peak for this one will appear at 2.5 or something, and this one will come around 1.3. It will not come at 1 because it is just one atom away. Okay? So like that, you can see in this one that there is one set of proton which is attached to the electron withdrawing group. Now, the splitting. This one has 3 neighbors.
Did you say 3.7 has one hydrogen or no hydrogen?
This one?
Yes. That's a zero, right?
I haven't told anything like about any hydrogen. I'm just talking about the set of protons.
Saying that it's oxygen.
Yeah, next to oxygen.
Next much.
In this one, it has 2 neighbors. This one, no neighbor. Okay. Same way, you can use this information if there are 3 neighbors, no neighbor, 2 neighbors. You are seeing just these two splitting. These two are splitted. It means one has 3 neighbors and this one has 2 neighbors. For a quartet and a triplet, and you only take, as I said before, one oxygen need one group, like one carbon will be attached, that will be this one, because it is appearing at 3.7. And from this information we can see the electron withdrawing group we can come up with is CO only. Now we are left with 2 other, and in this case one carbon will be here which will appear at 2.3. Around 2.3 that will appear because it is near to electron withdrawing atom. Now you have one carbon left. And whatever this one is, it has 3 neighbors. There is no other way you can put 3 protons to its neighborhood. You have to go this way only, and you have to put 3 protons over here. So with limited information we are restricting our choice which way we will grow the chain. Okay? Now this one which has which has 3 neighbors got a quartet. Now how many protons you can attach over here? Only 2. If you attach 2 to this one will split the peaks for this one in triplet. The peak for these 3 hydrogens will be triplet because these 3 got only 2 neighbors. Okay? Carbon has tetravalency, so 2, 1, 3, 1, 4. Now, how many protons you have left? 2 and 3. 5. You have 3 left. How many carbon you have left? 1 here, and this one has 3 valency left, so 1, 2, and 3. And there is no other way you can join these two fragments together to make one molecule. You have to put this O next to this one. Isn't it? Is there anything else possible? So let me erase this one from here and write O and CH3. Okay? So for this spectra, now we will go back. CH3, no neighbors, single single peak attached to an electronegative atom directly, which is oxygen, peak, a single peak around 4. Around 4, not exactly on 4, around 4, coming on 3.7. This one got 3 neighbors. We expect a quartet for this one around 2.1, 2.2, something like that. We are getting it at 2.3. Now this one got 2 neighbors. We expect a triplet far from an electron withdrawing group. So we will expect a triplet around 1.3, 1.2 or 1. Okay? We are getting around 1.2. This molecule perfectly explains this spectrum. Okay? So then only I will be satisfied that okay, this one is the molecule which I was looking for. Now, yeah.
What happened to the triplet 1.5? Where is that?
That one, these two are different spectra. This one is one spectra, that one is another spectra. We will come to that one. You are going to solve that one. I'm not going to solve. Okay. So this one, like, okay guys, now one thing, whenever you are solving it, whether it is an exam, whether it is your lab report, whether you are solving it for yourself or for someone else, please write a number or a letter to indicate one set of protons. So if you have written this, you write A, B, C, D. If you don't like ABCD, write 1, 2, 3. If you don't like that one, write in any language, make any symbol, but make it, okay? And then to assign the peaks, just write A, C, and D. That's it. Please don't draw like
Where's B? Where's B?
B has no protons.
So it's on A and B.
Here I am saying B has no protons, so no spectra for B.
No spectrum.
No.
Can't you just put CH3 on top of the or something? And then
Okay,
C
now-
double bond on
This one is CH3 here, and this one is a CH3 here. Which CH3 you want to mean with like once you write a CH3? Which CH3 I should understand?
we both know there's much.
If you want to write like that, write CH3O. Then I will understand, okay, you are talking about this one, not about this one. If you have to write CH3, CH2, write CH3, CH2. Now there is a confusion that which set of protons you are talking about. So you will say CH3, CH2 and make a circle or indicate it otherwise so that I can understand that you are talking about this one which is near to CH2 and I can look it up in your structure. Okay? Just avoid a mess on your graph. Now, I have given you the information. Some of you guys have already solved that spectra. Whosoever has not solved it, can you solve it for me now?
Can you explain to me one more time why the one CH3 has one big spike and the other CH3 has
This
this?
CH3 has nothing in it, no protons in neighbor. This CH3 has 2 protons in its neighborhood. So 2 protons will cause a splitting in peak and it will become 3. And it is far from electron withdrawing group, so it will stay near 1 in terms of its position.
So it's
Yeah. If it say, listen, if I extend this one to CH3 one more, then this 3 and 2, 5 neighbor will cause a splitting of 6. You will see this peak like, not like 2, 1, 2, 3, 4, 5, 6, like this. Because it has 3 on this side and 2 on this side. If I extend that, this problem was like this. I just wanted to explain you have to consider the neighbor on both the sides. Okay. So I guess no one wanted to solve that problem. Everyone wanted to leave. What? Whosoever has not solved the problem, I am asking those people. You guys have solved it. Whosoever has already solved it, they can leave now. Okay? And whosoever has not solved it, they want to solve it, then solve it. Otherwise, I am not going to win that problem. If you don't put any attempt, I am not going to
Why
solve
didn't
it.
you just solve it?
It's an easy one. It's an easy one. If you